Are you confused about what a process really is in Linux? By the end of this video, you will clearly understand what a process is, the life cycle of a process, the difference between foreground and background processes, what CPU scheduling means, and why Linux handles thousands of processes so efficiently. Let me start from the beginning. What is a process in Linux? A process in Linux is simply a running instance of a program. Here is the important distinction. A program is a file stored on disk. A process is that program loaded into memory and currently executing. When you try to open Chrome, before clicking it, it is just a program stored on disk. The moment you launch it, the Linux kernel loads it into memory and creates a process. Even something as simple as running ls command creates a process. So every action in Linux requires a process. Now, what does a process contain? Each process has a unique PID or process ID, its own memory space, CPU state, open files, environment variables, and owner. Linux uses the PID to track and manage processes. You can see processes using PSAUX. Now that we understand what a process is, let's understand its life cycle. The process life cycle is the series of state a process goes through from creation until termination. In simple words, a process is born, it runs, it may wait, and eventually it exists. Now there are 5 main states in a process's life cycle. First, new or created. When you run a command, the kernel creates a new process. It assigns a PID and the memory and resources are allocated. This is typically done using the fork system call. 2. Ready. The process is ready to run but waiting for CPU time, and it's placed in the scheduling queue. Then the scheduler decides when it gets CPU access. The third state is the running state. In this stage, the process is actively executing on the CPU, and only one process per CPU core can run at a time. Fourth stage is waiting or sleeping or blocked. Sometimes a process must wait for disk operations, network responses, user input, and input-output operations. In this state, it is not using CPU. The fifth and the last state is the terminated state and returns an exit status to its parent. You can check the last exit status with echo $. Now there are two kinds of processes, the foreground processes and the background processes. First, let's talk about the foreground process. A foreground process runs in terminal, takes the control of the terminal and blocks you from typing new commands. Example, if you type sleep 10, your terminal becomes busy for 10 seconds. Another example could be nano file.txt. Until you exit nano, you cannot type new commands. And then a background process runs without blocking the terminal. It allows you to continue typing commands. Example, if you type sleep 30 and the ant sends it to the background, you will see something like this. You can check background jobs using jobs. You can bring a job back to the foreground with FG command. Now, what is a CPU scheduling? This is a powerful concept. CPU scheduling is the mechanism by which the operating system decides which process gets the CPU and for how long. Since a CPU core can only run one process at a time, the system must constantly decide who runs next. That decision-making system is called CPU scheduling. And the reason why we need it, because hundreds of processes may exist at the same time. Many are ready to run. CPU cores are limited. If you open a browser, run a script, and play music, all of them need CPU time. The scheduler ensures fairness, efficiency, and responsiveness. Now you might think why Linux handles many processes so well. So Linux is designed as a multi-user, multitasking system from the beginning. And it is multitasking by efficient CPU scheduling, preemptive multitasking, strong memory management, creating lightweight process model, utilizes input and output efficiently, and designed for servers.